This is a lesson on exponential functions, and this is the form that they need to be in. So y equals a times b to the x power. So we can pretty much put anything we want in a. Generally speaking, though, this is kind of going to be a positive number in real life situations. So let's just pretend for a second that it's 5. And I'm going to plug in 2 in for b, and the variable stays in the exponent. So this would be an example of an exponential equation. Now, to make it a little bit easier to start out, since this may be the first time you've dealt with an exponential equation, I'm going to just get rid of the 5, which basically saying, I'm going to let a equals 1. So it's 1 times the 2 to the x. So it makes it a little bit easier to deal with. So this was just an example. This is the one that I want to work with. So what we're going to do is we're going to plug in some values. So we're going to plug in -2, -1, 0, 1, and 2. So we're going to plug in 0. Anything to the 0 power is 1. 2 to the first power is 2. 2 to the second power is 4. So these are all points. 0, 1, 1, 2, 2, 4. If I put in 3, I'd get out 8. If I put in 4, I'd get out 6. What happens when you have a negative exponent? 2 to the -1. Well, that's 1/2. 2 to the -2 is 1 over 2 squared, or 1/4. So again, those are just points. All right, so I've got 6 points to plot. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. Come on. And then 1, 2, 3, -1, -2. I could do -3 if I really wanted to. Again, I use a little blue dot. We have 0 giving us 1. We have 1 giving us 2. 2 gives us 4. 3 gives us 8. So you can see it really just increases pretty quickly there. And then when I plug in -1, I get out 1/2, 1/4, 1/8. And if I kept going out that way, I would get smaller and smaller numbers, except I wouldn't get 0. So the line gets really close to that x-axis, but never touches it. I didn't really do a good job of that right there. So it kind of does that, and then it goes through each of those points, and then it really goes up quickly from there. And that's what an exponential curve looks like. Okay, one end goes up, the other end goes towards 0. So let's take a look at this graph. Okay, again, that 1 is there. We don't really need it. So I'm looking at 1/2 to the x power. So I'm going to plug in 0, 1, and 2 and see what I get out. 0 gives me 1, no matter what. Plug in 0, you get out 1. Plug in 1, you get out 1/2. Square 1/2, and you get out 1/4. Plug in -1 and -2. You flip the fraction. You get 2, you get 4. Okay, if you need help with your power rules, you probably need to check out a different video. So here's my y-axis, here's my x-axis. 1, 2, 3, 4, -1, -2, 1, 2. So we have 0, 1. We have 1, 1/2, 2, 1/4. -1, 2, -2, 4. And if you look at that, it's going to be exactly the opposite shape. So it's going to get infinitely close down here. It's going to get close to infinity over here. And that's a quick look at exponentials. Now, there's a particular reason why this happens. This number right here, the b value, it all has to do with the b value. Okay? B has to be greater than 0. On the first example, b was 2. In fact, b was greater than 1. All right? So if it's greater than 1, is it greater than 0? Yes. If it's less than 1, so if b was between 0 and 1, like for when it was 1/2, you get a decreasing situation. And for when it is above 1, you get an increasing situation. So it doesn't really matter if it was 1.5, it would be a little more gradual. If it was 10.5, it would be, let me do that in a different color, 10.5, or just 10, it would be much steeper like that. All going through the same point, there's really. And then over here, if I had 1/10, it's going to be much closer to the x-axis sooner. And then if I had something like 2, not 2, that doesn't make any sense, 0.9, it would be more gradual. Okay, so the key is if it's between 0 and 1, if it's a fraction or a decimal less than 1, then it's going to be starting high and ending low. If it's the other way around, if it is a larger number, it's going to start near 0 and then go towards infinity. Doesn't matter which one it is. And that's exponentials.